Okay, so this video is going to talk about what we discussed on Friday with the area of sectors. We've already discussed this a little bit without really calling it a sector on the day we did the composite figures. Um, so you'll hopefully see some connections to that kind of stuff. So first of all, just what is a sector? A sector is just a fractional part of a circle. So really what you want to be thinking about when you see, when you hear that word sector is think about like a pizza slice. So here we've got an example of a sector in pink. Oops, moving stuff around. There we go. And the one big thing you might want to think about with these is this central angle here. This is called our central angle. We usually use just theta if we don't know what it is. But for now, we'll start with knowing what that angle is. That is going to help us figure out what part of the circle we're talking about, because we know the whole way around a circle is 360 degrees. So when we're thinking about that fractional part, it helps us compare like what part, the theta is the part out of the whole circle, are we actually dealing with. That's our fractional part of that circle. Now, yesterday when we were talking about composite figures, we had half circles showing up quite a bit. And what we talked about then was, well, if we have a half a circle, we can just take the area of our whole circle, pi r squared, and divide it by 2 because we've got half of a circle. Now, one thing I want you to be thinking about right now is dividing by 2 is the same thing as just multiplying by 1/2. So if I did 1/2 times the area of my circle, that would also get me the same exact thing. This part here is just the area of the whole circle. Oops, maybe. So this part here is just the area of the whole circle, and this part here is just the fraction of the circle I'm dealing with. If we were looking at something like this one, which is a quarter of a circle, we would just have 1/4 times pi r squared. Again, the area of the circle times whatever fraction of the circle we're dealing with. That's really all it is when we're talking about sectors. So for example, something like these would be a little bit more, specific to some cases you might see. Right here, I've got 1/5 of a circle. You can see that right here. So that's 1/5 of a circle. So I have 1/5 times pi. This time I know the radius is 5, so pi times 5 squared. Or if I have 3/8 of a circle and the radius is 12, so 3/8 times pi times 12 squared. I could find the area of that sector by just taking whatever fraction it is. So I'd have whatever fraction it is times the area of the whole circle. Anytime you see that word of, it's a fraction of a circle. In math, you're always multiplying. Now, the big thing you might still have a question about is, well, how in the heck did I know that that was 3/8 of a circle? Or how did I know that that was 1/5 of a circle? Yeah, that thing is going to fit in 5 times, but you don't know that just by looking at it. And so that's where I can use that central angle to help me out. I know that central angle of 72 degrees is out of a total angle of 360 degrees for the full circle. If I simplify that fraction, I get 1/5. If I take my 135 degrees here out of the total of 360 and I simplify that fraction, I get 3/8. And we could certainly simplify those by hand, dividing by 5 on both of them until we, dividing top and bottom until we get to the same number. But this is something you can also use a scientific calculator to help you out with. So if I've got 72 degrees and I want to figure out what fraction of that circle it is, I can just take 72 divided by 360, and Desmos will give me a decimal by default, but it'll also convert it to a fraction for me. And that'll be the same thing if I take my 135 degrees divided by 360 and convert that to a fraction, it'll give me my 3/8. So one of the first things I want to do is just a little bit of practice with, what are the fractions of circles? So here, if I had 160 degrees and I want to know what fraction of the circle it is, so I'd have 160 degrees is my part, 360 degrees is my whole, and I could simplify that to, whatever it's going to end up being. So if I pull up Desmos here, 160 degrees divided by 360 degrees was 0.4, but that's 4/9 as a fraction. So this is 4/9 of my circle. If I wanted to find the area, well, I know how to find the area of that circle. It's pi times 3 squared. And I'm just going to multiply that times 4/9 to get my area of the circle. Now I can also ask some questions going the other direction. So example, what central angle would give you the 3/5 of a circle shown below? So this, we're trying to figure out, well, what is that angle? I know the whole thing is 360 degrees, and I know I have 3/5 of it. Well, 3/5 of 360 degrees just means to multiply. So 3/5 times 360 degrees, that can go straight in your calculator. So 3/5 times 360 degrees, that's 216 degrees. So in this case, I'm using that to find my central angle. The whole angle in the middle is 360 degrees. 3/5 times that angle measure gives me what angle measure I want. But I can also do something very, very similar to find the actual area of a sector. So if you ever were to look up the area formula for a sector, you'd find something like this. But I want to just break down what this area formula is. In blue here, all I've got is my fraction. Right? That is what fraction of the circle I'm talking about. I know my total angle is 360 degrees for the whole way around. Theta is my central angle, so that is the angle part that I want to find the sector for. And then I'm just multiplying it by it because the fraction of the area. And I'm just multiplying that by my area formula for the whole circle. So whatever fraction I have times the area of my circle, that's the area of my sector. It's just some piece of it. It might be 1/5, it might be 3/8. And honestly, we don't even really need to simplify this. So if we're going to be typing this into a calculator like Desmos, typing in 72 over 360 is going to give me the same answer as typing 1/5. They're equivalent fractions. If I'm using a calculator, I don't even need to simplify it. So just a few examples here. Here I've got a 45-degree angle and a 6-yard radius. So my fraction is 45 out of 360 of my circle would be pi times the radius squared. And that is going to be my area of my sector. Right? It's whatever fraction of the circle. So at this point, I could start by simplifying this all by hand if I wanted to, but this is also a place where I could just take a calculator like Desmos and go ahead and start typing this in. 45 over 360. Make sure you arrow over so you're not in the denominator anymore. Times pi times 6 squared. And that will be my area. Whatever they're asking you to round to, make sure you're rounding appropriately. If you're in my class and you're doing delta math, they ask you to round to the hundredths spot. Hundredth spot is 2 decimals, so if I have 14.137 and I want to round to that hundredth spot, the 7 tells me to round that up to a 4. So 14.14 square yards. It really can be as simple as just plugging in your angle and your radius. Right? You've got a fraction, you've got an area of a circle. If I'm looking at something like this, very, very similar deal. Again, I'm just going to think about this as a fraction of a circle. It is 150 out of 360. That's what fraction I have this time. Times, or of, my circle, which is pi times the radius of 2 squared. And I can simplify that as much or as little as I want. I know I'm just going to be putting this into a calculator. So 150 divided by 360 times pi times the radius of 2 squared. And if I round that to the nearest hundredth, that'd be 5.24. Rounding it up because of the 5 in the thousandth spot. So 5.24, and this one is also in yards for some reason. Yards squared, or square yards. So that's area of sectors. It's really a fairly simple thing once you understand that it's just whatever fraction you have times the normal area formula of a circle.